I want to take you on a journey through the cosmos where science and faith converge in unexpected ways. We're not here to prove God's existence through scientific methodology. Rather, we'll examine how multiple, independent lines of evidence from physics, cosmology, and history form a coherent intellectual framework in which theism becomes a compelling explanatory hypothesis. Now, let's consider the foundational discovery of modern physics. The existence of a life-permitting universe depends on a delicate and improbable balance of fundamental constants and quantities. These values aren't predicted by any overarching theory. They're brute facts of our cosmos that must be determined empirically. Take the strong nuclear force, for instance. If it were just 2% stronger, all hydrogen would have fused into unstable diprotons during the Big Bang, preventing the formation of long-lived stars as we know them. Conversely, if it were about 5% weaker, stellar nucleosynthesis would be too inefficient to create any elements beyond hydrogen. The universe as we know it simply wouldn't exist. Perhaps the most striking example of fine-tuning is the cosmological constant, which governs the expansion rate of the universe. Its value is observed to be incomprehensibly fine-tuned to 1 part in 10 circumflex 120. To put this in perspective, that's like throwing a dart across the entire observable universe and hitting a bullseye 1 atom wide. If this constant were slightly more positive, cosmic expansion would have been too rapid for gravity to pull matter together into galaxies, stars, and planets. If it were slightly negative, the universe would have collapsed back in on itself moments after its birth. We must ask ourselves, how do we explain this level of precision? Is it mere chance, or does it point to something or someone beyond our universe? Let's narrow our focus from the cosmic to the local. Beyond the fine-tuning of universal laws, the existence of complex life on Earth depends on a cascade of improbable and finely balanced local conditions. This line of reasoning, known as the rare Earth hypothesis, argues that while microbial life might be common, the conditions needed for complex, intelligent life are exceptionally rare. Consider Earth's position in the cosmos. We're situated in what astronomers call the galactic habitable zone, a narrow ring where conditions are just right for life. If our solar system were too close to the galactic center, it would be sterilized by intense radiation. Too far out, and there wouldn't be enough heavy elements to form rocky planets. This safe zone is estimated to contain no more than 10% of the galaxy's stars. It's crucial to understand that Earth's habitability isn't just about its distance from the Sun. Many discovered exoplanetary systems feature hot Jupiters, gas giants orbiting very close to their star, which would disrupt or eject an Earth-like planet from the habitable zone. The specific, stable configuration of our solar system has been essential in providing the long-term, relatively tranquil environment needed for complex life to flourish. The leading theory of the Moon's origin, the giant impact hypothesis, suggests it was formed from the debris of a collision between the proto-Earth and a Mars-sized object. The Moon's gravitational pull is the primary force stabilizing Earth's axial tilt at a near constant 23.5 degrees. Without this stabilizing influence, Earth's tilt would wobble chaotically over geological time, leading to extreme and unpredictable climate swings that would render the planet's surface uninhabitable for complex organisms. This model, now the standard in cosmology, demonstrates that all space, time, matter, and energy burst into existence from a single point, approximately 13.8 billion years ago. For most of scientific history, the prevailing consensus was the opposite, an eternal, static, uncreated universe. The universe did in fact have a beginning. This resonates powerfully with the Judeo-Christian creation account, which has long declared, "In the beginning, God created the heavens and the earth." A common objection to this harmony is the apparent conflict between the 6 days of Genesis and the 13.8 billion year cosmic timeline. One such model is the day-age theory, which notes that the Hebrew word for day, yom, can signify not only a 24-hour period, but also a longer, indefinite era or age. Another fascinating model, proposed by physicist Gerald Schroeder, uses Einstein's theory of relativity to reconcile the timelines, showing how 6 24-hour days from the perspective of the early universe could indeed equal billions of years from our current earthly perspective. Archaeological evidence provides powerful tools to verify the Bible's historical claims. The Tel Dan Stele provides the first extra-biblical evidence for King David's dynasty. The Moabite stone mentions King Omri of Israel, corroborating biblical accounts of regional conflicts. Hezekiah's tunnel, built to protect Jerusalem's water supply, matches the biblical description exactly. The Pool of Siloam, discovered in 2004, confirms the geographical accuracy of John's Gospel. The historical reality of Jesus Christ is supported by both Christian and non-Christian sources. Tacitus, a respected Roman historian, confirms Jesus' execution under Pontius Pilate. Flavius Josephus, a prominent Jewish historian, references Jesus as a wise teacher in his works. Returning to the cosmic scale, let's consider the formation of carbon, the backbone of all known life. In the 1950s, astronomer Fred Hoyle made a remarkable prediction about carbon formation. Hoyle predicted a specific property of the carbon-12 nucleus that makes its formation possible. This prediction was confirmed, revealing another layer of fine-tuning in our universe. As we've seen, multiple independent lines of inquiry, from physics, geology, cosmology, and history, all point toward a single, coherent conclusion. The universe is consistent with the work of an intelligent and purposeful creator who has revealed himself in nature and in history. In conclusion, the evidence presented does not compel belief, but it establishes a robust intellectual foundation for it. It suggests that the universe is not a meaningless accident, but a creation imbued with purpose. It frames theism not as a blind leap of faith in opposition to science, but as a powerful explanatory hypothesis that accounts for a wide range of data. As we conclude this journey through the cosmos and history, I want to emphasize that what we've explored today is just the beginning. The relationship between science and faith is rich and complex, offering a lifetime of study and contemplation. I encourage you to continue asking questions, to dig deeper into the evidence, and to approach both scientific discovery and religious belief with an open and critical mind. Thank you for joining me on this exploration of cosmic design and divine revelation.